All right, y'all. This is sort of a review of some Algebra 2 stuff about transformations, but we're only going to be using function notation. Okay, so all of these things are function notation. Right? Anytime you see F's with a bunch of letters, this is all function notation. Okay, which is probably what makes this the hardest thing is there's not very many equations floating around here like you're used to seeing from Algebra 2, right? Everything is very, mathematical, and we're not used to looking at mathematical things. So we have 4 different types of transformation, actually 2 types of transformations. We have vertical and horizontal translations. Okay, so a translation is some type of a slide, a left to right or a vertical type of a movement. Okay, now the thing you need to remember about vertical translations is that your sign tells the truth. So if you have a plus, that moves your value up, all your points up that many. And if you have a minus, it moves it down. So here's an example. Here we have the graph of F, which looks like this, right? It is 3 line segments that have been connected together. And this says to move each of your y values. Remember, it's kind of important to remember f of x means y values, right? These are the y values from your f graph. The x's are not being affected, right? This says f of x minus 2. Subtract 2 units or subtract 2 from each of your y values. Notice the x values are not affected. It is not moved left or right. So that means we're going to move each of our y values down 2 units. 1, 2 puts it here, right? There's another point goes here. This one actually should be back up here on the x-axis, right? This example is not a very well done one. I apologize, because it is moved down 3, which is not good. Everything has to have that same translation to it. So this would be the graph of G, not this part. Okay, so everything has been moved down 2 units for our function, right? The y values. The y values are 2 less than what they used to be. Okay, and then we have your horizontal translation. Now, horizontal translations, you may have learned, your sign is always lying to you. Okay, so a plus in your parentheses moves your graph to the left, and a minus in parentheses moves your graph to the right. Okay, that's because of what happens when we solve this. If we were to solve x plus 2 equals 0, what number plus 2 equals 0? Negative 2. And a negative is a left direction translation. Okay, so here we have f of x minus 2, each of our points, each of our x points, right? So these are x values. Each of your x points have been moved 2 units to the left, or they have been subtracted 2 to give us our G graph, which is all of these are 2 units to the left of where they originally were. Okay, so your horizontal translation, anything in parentheses, is actually the opposite of what it says. Okay, and now we have your vertical dilation. So dilations are stretches and compressions. That's what we used to call them in Algebra 2. So if we had a number bigger than 1, it was a stretch, and if we had a fraction less than 1, we called that a compression. Okay, so we're going to combine them and just call it a dilation, a vertical dilation, by a factor of whatever your A happens to be. Okay. Now, of course, if A is negative, then that's a reflection. Like here we have negative 2. So this says, and this is really important, this is telling you to multiply each y value, because f of x means y value. So this is your y value. Multiply each of your y values by negative 2. That's what this is telling us to do. So let's see how that affected our graph. So here we have a y value of positive 1. Positive 1 times negative 2 is negative 2, right? It's been moved down there. Here I have a y value of negative 1. Negative 1 times negative 2 is positive 2. It's been moved right there. Okay, now all these have y values of positive 2. Positive 2 times negative 2 is negative 4. Okay, so if it just has an f of x, that's telling you to change the y values only. The x coordinates don't change. The y values get multiplied by negative 2. So if we want to look at it as a point, so here we have this point. This is the coordinate 3, 2. Right, if I were to multiply the y value by negative 2, it ends up at 3, negative 4. Right, the x coordinate is not affected. Only the y value has changed. Okay, and then we have a horizontal dilation. Now look at this, because this always messes kids up. Okay, so here I have a number, but look at what the actual factor becomes. Right, it's the reciprocal. So if I have multiplication inside of my parentheses, that's actually a dilation by a fractional amount. Okay? Remember, this is always reciprocal. The parenthesis thing always tells you the opposite. So minuses mean they go right. Multiplications mean you're actually dividing. Okay, actually dividing. So a dilation, right? That's what a dilation does for our thing. This is simply multiplying all of your x values by negative 1, right? It says change all the x values to negative, so that's a reflection over your y-axis, right? This was the point 3, 2. Now it's the point negative 3, 2. The y hasn't changed, only the x has for this functional transformation. Okay, so that's kind of a review of what you learned in Algebra 2 about functional transformation and their notation. Okay, so then this next table talks about some things, some notes and tips, right? So you can look at this if you want to. But as we practice these, hopefully you won't need to know these tips. They will just become brain functions. So example 1. Let g be the function. So g, we're saying g is this equation. Notice it's in function notation. So 2 times f of x minus 3 plus 1. So describe the transformation. So how many transformations do you see? 3 of them. We have the 2 out front. That's one transformation. We have the minus 3 in parentheses, and we have the plus 1 after your function. So each of these do different things. So what does the 2 do? This is a vertical dilation by a factor of 2. Okay, we used to call this a stretch, but we're just going to combine your stretch and compression into a vertical dilation by a factor of 2. Okay, what does the x minus 3 do to our function? This is a, no, parentheses lie, so minus goes to the right. This is a right 3-unit translation. Our function has been moved right 3 units. Parentheses lie. So a minus in your parentheses means you go right that many units. And then what does the plus 1 at the very end do to our function? Moves it up 1 unit. So you can write translated up 1 unit, translated right 3 units. But this is sufficient for us to do. Okay, so let's see what we have for example number 2. Here we have a function g, and we have 3 transformations in this order. First, we have a horizontal dilation. Horizontal dilation. by a factor of 3. And we have a vertical dilation by a factor of 4. And then a vertical translation. Okay, and it's telling us that this is our form, right? This is our form. So what does the A represent? This is your vertical dilation. The A is represented by your vertical dilation. What does the B represent? Your horizontal dilation. And then C represents your vertical translation. Okay, so we have translations and dilations. So in this order, so g of x is equal to f of something x. So our horizontal dilation of, what was my factor? 3. So if I have a multiplication factor of 3, what does my coefficient look like? That would be a 1/3, right? It says a factor of 3, so like we saw in the notes before, we write the reciprocal of that inside of our parentheses. Okay, so if we have a 1/3 in front of x, that is a horizontal dilation by a factor of 3. Parentheses always lie. So that's division by 3 is what we write when it's truly multiplication by 3. Okay, what goes in front? What is my vertical dilation? A 4, so that's normal. We put a 4 out front. Nothing wrong with that. And then we have a vertical translation of down 7, so -7, right? Vertical translations don't ever change. They stay the exact same. So not 7 units down. It could say 7 units down, but this says a translation of -7 units, so you have a -7. Only when it goes inside of your parentheses does anything change from what we are given. Okay, so let's see if we can do that with this graph. This graph has some line segments and a semicircle. And there is the domain of our graph, -3 to 5, right? This is the domain. These are your possible x values. Okay, graph some g that has this as its equation. So f of x plus 3, what direction does every x value go? Left 3 units. We go with the x values, and our y values go 4 units down. So we're going to do this with every point. We're going to move it 3 units left and 4 units down. Okay, so here we have some points. Here we go. We'll start here. Just count 1, 2, 3 left and 1, 2, 3, 4 down. That's where this new point is going to end up. And we do that with all of our points. 1, 2, 3 left, 1, 2, 3, 4 down. Okay, we'll do it with the other side of the semicircle. 1, 2, 3 left, 1, 2, 3, 4 down. And then our last point, 1, 2, 3 left, 1, 2, 3, 4 down. Okay, so it's pretty easy to do your line segments. They're pretty straight. But what's the radius of my semicircle? That is 1.5 units. So I'm going to come from my middle, and I'm going to put that dot there in the middle of that box. And I'm going to do my best to make a nice looking semicircle in between an x of -3 and an x of 0. Okay, let's see if we can make sense of our next thing. The domain is from -3 to 5, right? Those are your x values. And the range was from 1 to 3. Does that look right? A range value from 1 to 3? These are our possible y values. Yep, I would agree. Okay. Find the domain and range of this. So how is this changed? So what are we going to do to all of our x terms? What does this say to do to your x term? That says left 3. So we're going to subtract 3 from each x value. And where do we find your x values? From your domain. Right? Your x values are your domain stuff. So anything in parentheses affects your x values and your x values only. So here are your domain. What happens when I subtract 3 from each of these terms? Negative 3 minus 3 becomes negative 6, right? And we have your less than x less than. 5 minus 3 is 2. So we have an x domain of negative 6 to positive 2. Okay, is that true over here? Is that what we did? Yes, looks like we have a negative 6 to positive 2. That looks like it's our new domain. Makes sense. Now, what's happening to our y values? What's going on with the range here? Well, first we're going to multiply your y values by 2. First we multiply your y values by 2. Okay, so that's it. What are your y values? Your y values are your range, right? Your range are your y values. So multiply all of our y values by 2. And what do we get? 2 is less than y is less than or equal to 6. Right? You multiply only your numbers. You don't do the y. The y is your letter, your variable. So you multiply each of your y values by 2. Right? So our range has just been adjusted. What else do we have to do to our range? Subtract 4, right? We have to subtract 4 from all of your y values now. Okay, so minus 4. So we subtract 4 from each of your y values. 2 minus 4 is negative 2. 6 minus 4 is positive 2. So this would be the range after those translations, and that's your domain after the translation. Okay, so the x things only affect x values, and the y things only affect y values. Okay, so here we have a table, right? AP loves to give you tables. And we're defining this as some function we're calling p. So these are your x values, right? X values are your independent variables, negative 2, 0, 2, 4, 6. And these are your y values for your p function, some p function. We don't even know what it is. But then h is this, right? H is related to your p function in these different ways. So first of all, you're going to multiply your x value by 2. Right? And then we're going to multiply, well, then you're going to find the p of that. And then you multiply that value by 3, and then finally you're going to subtract 1. Okay? So see these orders of operations. So we start with h of negative 1. So this is your x value. Remember, it's 3p of 2x minus 1. So we have an x value of negative 1. Okay? So that means we're going to replace x with negative 1. So 3p of 2 times negative 1, right? You put negative 1 in for your x, minus 1. Okay? And now we work from inside to out. What is 2 times negative 1? Negative 2. So we still want p of negative 2 times that by 3 and then minus 1. Okay? So here is your maybe potentially new. Where do we get this value from? This value comes from your table, right? This comes from the table. When my x is -2, what's my p-value? It's 1. So p of -2, when x is -2 from your table, p-value is 1. So I replace p of -2. The whole thing is just the number 1. So now we can do our elementary math. 3 times 1 is 3. 3 minus 1 is +2. So our answer is +2. Okay, here we have h of 2. So remember, this is your x value. So that's 3 times p of 2 times 2, right? So your x value is 2. So we replace x with 2 in your equation up here, right? It's the purple equation. And now we do our math from inside out. What is 2 times 2? Right, that's 4. And now we have to do p of 4. So this comes from your table, the whole thing, p of 4. When x is 4, p is 3. When x is 4, p is 3. So what's 3 times 3 minus 1? 8. So our answer is 8. Okay, we're evaluating using a table rather than using an equation. So now we have an x value of 0. So 3p of 2 times 0 minus 1. Okay, so 2 times 0, well, that's just 0. So now we go to our table. What is the y value when x is 0? It is -1. So this becomes a -1. Times it by 3. 3 times -1 is? -3 minus 1 is -4. Okay, so when we have these types of problems where we have a function based upon a function and we're using a table, you replace your letter from the table. Okay, so that's how we do some of these things with domains and ranges with our functional notation. Have a swell day.